Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course. States of matter. Today we begin with lecture 18 from the course, but make sure you watch the previous ones before viewing this one. In the last lecture, we learned what is the Dalton's law of partial pressures. So I hope the concept is clear to you because in this lecture, we are going to see a few problems based on the Dalton's law. And this is going to be a really helpful lecture for you people because here you are going to see a few questions which are going to help you understand the law better. This is going to give you an idea what type of questions they are going to come in the examination, how you are going to attempt those questions so that once these questions that do come in the examination, well, you can attempt them confidently, score good marks, and this is going to lead you to a good college that you are aspiring for. Right? So let us see a few problems based on the Dalton's law of partial pressures. So the first question is that a neon-dioxane mixture contains 70.6 gram of dioxygen and 167.5 gram of neon. If the pressure of the mixture of gases in the cylinder is 25 bar, what is the partial pressure of dioxane and neon in the mixture? Okay, so here we have a mixture of two gases, and then gases, they are non-reactive in nature. So this is going to be a question of Dalton's law of partial pressure, right? So this is clear. Now what we are given is the amount of the two gases. We are given the total pressure. What we have to find out is the partial pressure, right? So the partial pressure of each gas is going to be equal to the mole fraction multiplied by the total pressure. So what do we require? We require the mole fraction of each gas, and for that the first step is going to be finding out the number of moles of each gas. So let us do that. So first of all, the number of moles of oxygen, this is going to be the mass divided by the molar mass. So 70.6 divided by 32, this will give you the moles of oxygen, that is 2.21 moles. Similarly, the moles of neon, 167.5 grams, the mass of neon that is given to us divided by the molar mass, that is 20. So you will be getting this as 8.375 moles. Now we have to find out the mole fraction of each gas. So the mole fraction of oxygen is going to be the number of moles of oxygen divided by the total number of moles of both the gases. So this is 2.21 divided by 2.21 plus 8.375. This will be 0.21. The mole fraction of neon, this is going to be 8.375. The number of moles of neon divided again by the total number of moles, this will come up to 0.79. Also you can do as 1 minus 0.21 because the sum total of both mole fractions is going to be 1, right? So 1 minus 0.21 is also again going to give you as 0.79. Okay. Now once you have found out the mole fraction of both the gases, the partial pressure of a gas is going to be equal to mole fraction of the gas into the total pressure. So the mole fraction of oxygen was 0.21 multiplied by the total pressure, which is 25 bar, is going to give you the partial pressure of oxygen to be 5.25 bar, and similarly the partial pressure of neon is going to be 0.79. The mole fraction of neon multiplied by the total pressure, this is going to be equal to 19.75 bar, right? So I hope this is clear how we are going to deal with such questions. Now the next question is that a gaseous mixture containing 50 gram of nitrogen and 10 gram of oxygen, they were enclosed in a vessel of 10-liter capacity at 27 degrees Celsius. So calculate the number of moles of each gas, the partial pressure of each gas, and the total pressure of the gaseous mixture. So how are we going to do this? You can try it yourself as well and then look at the solution. So the first part is we have to find out the number of moles of each gas. So let us do that. So what is given to us is the volume of the vessel, that is 10 liter, the temperature, that is 300 Kelvin, because the temperature given to us is 27 degrees Celsius. So 27 plus 273 is going to be 300 Kelvin. So to calculate the number of moles of each gas. What do we require? The mass of each gas divided by the molar mass. So let us quickly do that. The mass of nitrogen given is 50 gram. Molar mass is 28. So the moles of nitrogen is going to be 1.79. Weight of oxygen is 10 grams. The molar mass is 32. So 10 divided by 32, the number of moles of oxygen is going to be 0.31. So this is as far as the first part of the question is concerned. The second, we have to find out the partial pressure of each gas. So how do we do that? For this, now the total pressure is not given to us. So when the total pressure is not given to us, we are going to individually find out the pressure of each gas as it would be if it was present all alone. So what are we going to do? We are going to apply the gas equation PV equal to nRT. So pressure of each gas is going to be equal to the number of moles multiplied by the gas constant multiplied by the temperature divided by the volume of the container. So this is going to be the volume of the container because each gas is behaving as it is present alone. Fine. So the partial pressure of nitrogen is going to be equal to the number of moles of nitrogen multiplied by the universal gas constant. The value is 0.082 liter atmosphere per Kelvin per mole. Fine. And this temperature given to us is 300 Kelvin. The volume is 10 liter. So the partial pressure of nitrogen is going to come up to 4.40 atmosphere. Similarly, the partial pressure of oxygen, when you're going to put the value of number of moles of oxygen over here, you are going to get the partial pressure of oxygen to be 0.76 atmosphere. So we have found out the partial pressure of each gas from the number of moles of each gas, the volume, the temperature, and the universal gas constant value you already know. So this is how you will be finding a partial pressure of each gas, and then finding out the total pressure of the gaseous mixture. This is going to be the sum total of both according to the Dalton's law. So P total is going to be Pn2 plus PO2, and this is going to be 4.40 in plus 0.76. So this will come up to 5.16 atmosphere, right? So I hope you are understanding how we are doing these questions. Now the next question is that equal weights of ethane and hydrogen, they are mixed in an empty container at 25 degrees Celsius. The fraction of the total pressure exerted by hydrogen is, and the choices they are given as 1:2, 1:1, 1:16 and 15:16. Now this is a question which was asked for the entrance examination for IIT in the year 1991. Also in the year 1984, and a similar question with different gases also in the year 1981. Okay, so this is a very simple question once you have a thorough understanding of the concept. So first of all, you try the question yourself and then look at the solution. If you get that correct, very nice. If you do not get it correct, at least you will be knowing where you are committing a mistake. Okay, so that you do not commit that mistake again while you're attempting the question in your examination. It is very important, whatever questions that we discuss, you should do them first yourself. We have already discussed what is the concept behind these questions, so it is very much important that you do the questions yourself and then look at the solution. So I should not be keep on repeating this again and again, that please do attempt this question yourself. Do that automatically. See the question, try it yourself, and then look at the solution. Now, once you have done that, let us see how we are going to do this. So we have ethane and hydrogen. They are non-reactive in nature, and when they are non-reactive, well, if you have to find out the relationship of the pressures of the gases, well, it is going to be in accordance with the Dalton's law. So now what is given to us is that both the gases, they are of equal weights. Let that weight be W. Fine. And we have to find out the fraction of total pressure exerted by hydrogen. And well, for that, what you require is the partial pressure of hydrogen to the total pressure. So what we need, we want to find out the first of all the partial pressure which is going to be exerted by hydrogen. So partial pressure of hydrogen is going to be what? Well, you have already learned this. This is going to be mole fraction of hydrogen multiplied by the total pressure. Fine. So what is going to be the partial pressure of hydrogen? This is going to be mole fraction, and mole fraction is nothing but the number of moles of hydrogen divided by the total number of moles of both the gases, and multiply this by the total pressure is going to give you P hydrogen. Okay. So how are we going to find out the number of moles of hydrogen? Well, that is going to be simple. W by 2, the molar mass, and moles total of both the gases is going to be W by 2 plus W by 30. 30 is the molar mass of C2H6. So calculating this, what you will be finding is 15 by 16 into P total is the P H2, that is the partial pressure of hydrogen. Now partial pressure of hydrogen to the total pressure is going to be equal to coming up to 15 by 16 into P total divided by P total. So that is 15 by 16. So the correct choice is going to be 15 by 16. A very simple question asked for an IIT entrance examination. This is going to really help you score really well. Just understand the concepts, right? Practice a few questions and it is going to be very easy for you to score well. The next question is now a comprehension based question. The comprehension based questions, they do come in the IIT entrance examination, but this does not mean that the medical entrance students, they do not have to understand these questions, because this can come as a comprehension, this can come as an individual question. What we require is to have a thorough understanding of the concept, right? So the question is that consider the diagram to answer the questions, and the diagram is given to you now, and the comprehension says that initially there was a flask A which contained oxygen gas at 27 degrees Celsius and 950 mm of mercury, and flask B contained neon gas at 27 degrees Celsius and 900 mm of mercury. The two flasks, they were joined by a means of narrow tube of negligible volume equipped with a stopcock, and the gases, they were allowed to mix up freely. The final pressure in the combined system was found to be 910 mm of mercury. And what you have to do as the questions for the this comprehension is, the first question is, what is the correct relationship between the volumes of the two flasks? The choices, they are given to you. Next is that if the volume of the flask B was measured to be 10 liters, the mass of oxygen present in the flask A was, again the choice is given. And the third question is, how many moles of gas are present in flask A in the final condition, and the choices, they are given to you. So we will look at the question step by step, and we will see all the questions how we are going to solve them. So this is the comprehension that was given to us and the diagram. So let us see what is asked for the first question. What is the correct relationship between the volumes of the two flasks? So now what is given to us is that we have flask A, which is consisting of oxygen gas. The temperature is 27 degrees Celsius. So 27 plus 273 is 300 Kelvin, right? The pressure of the gas, that is oxygen gas, is 950 mm. So we are writing this as PA to be 950 mm. Okay. Now in the flask B, we have neon gas. The temperature is again 300 Kelvin because it is 27 degrees Celsius, and the pressure of neon gas is 900 mm, which we have labeled as PP. Okay, and the P total, which is given in the combined system, is 910 mm. When we have opened the stopcock, these two gases, they are going to mix with each other, and the pressure which we will be getting is as 910 mm of mercury, right? So what is going to be P total? With this, we have already learned the derivation in the last lecture while we were talking about the Dalton's law, where we did the mathematical deduction of the Dalton's law. Okay, so this is the equation that we got over there, that P total is going to be equal to PA VA plus PB VP divided by VA plus VP. In case you do not understand how we have got this, please go back and watch the lecture again so that you have an understanding how we got this relationship. Okay, so now we have the P total given to us as 910. Put the values of partial pressure of oxygen gas, neon gas, you will be getting this as the equation. When you're going to solve it, you will be getting VB equal to 4 VA. So the volume of neon gas, this is 4 times the volume of oxygen gas, and the correct choice is therefore going to be the B choice. Now for the next question, again putting back the comprehension for you so that you have an understanding, and the question that is now for us is that if the volume of flask B was measured to be 10 liters, the mass of oxygen present in flask A was, and the choices are 2 gram, 4 gram, 8 gram and 16 gram. Okay, now this is a comprehension based question, so what all calculations we have done for the previous question, we are going to put that into use. In case you have an independent question, well, you have to find out first what we've already found out, and then you will be doing for calculating further. So what we have already found out in the previous question is that the volume of the neon gas, that is VB, this is 4 times VA. So that relation I'm going to put into use over here. So we have VB given to us as 10 liters, right? So the volume in flask B is 10 liters. So the volume of flask A is going to be 10 by 4, and we are going to put PAVA equal to NART. Fine. This is before the stop cock was opened, right? So this is initially what we have to find out, what was the mass of oxygen present in flask A. So when we are going to find out that, what we have is the pressure, which was because of oxygen. The volume of this vessel is going to be equal to NART. So number of moles of oxygen multiplied by the gas constant multiplied by the temperature. So the pressure, if we take out that in atmosphere, we will be dividing 950 by 760 to get the pressure in atmosphere, multiplied by 10 by 4, which is the volume of the vessel A. This will be equal to W by 32 into the gas constant into the temperature, and you will be getting the mass of oxygen in flask A to be 4 grams. So the correct choice is going to be B. I hope you are getting these questions, how we are handling them, how we are treating each and every part, what all questions they can be asked you in the examination. You are having a thorough understanding now. So now the third question is, how many moles of gas they are present in flask A in the final condition. So this means that now the stopcock has been opened up. Oxygen and neon gases, they have mixed with each other. So what is going to be the pressure now in flask A? The pressure is going to be that which is of the combined system, that is 910 mm of mercury. So if you have to find out the number of moles of gas which are going to be present in flask A, the volume is going to be that of the flask A. The pressure is going to be the total pressure. So what we will be having as the relation is P total into VA is going to be equal to nRT, the number of moles of the both gases that are going to be present. So this is going to be equal to 910 divided by 760, so as to get the pressure in atmosphere, multiplied by 10 by 4, that is the volume of flask A, equal to N into 0.0821 into 300, right? So the value of N, that is the number of moles of gas present in flask A, is going to be 0.122, and the correct choice therefore is going to be the B choice, right? So I hope these questions, they are clear to you, how we are going to deal with such questions. Now, final question for today is what we learned in the application of the Dalton's law of partial pressure when we found out what is aqueous tension. How do we find out the pressure of a gas which is collected over a liquid, right? So based upon that learning is the last question, and the question says that a gas occupies 100 ml when collected over water at 15 degrees Celsius and 750 mm pressure. It occupies 92 ml in the dry state at NTP. Find the vapor pressure of water or the aqueous tension at 15 degrees Celsius, right? So aqueous tension is the vapor pressure of water. Whenever a gas is collected over water, some of the water vapors, they are going to be also present. The gas is going to be saturated with these water vapors, so this is going to affect the pressure that is being exerted by the gas, right? So based upon this learning, let us see how we are going to do the question. So the aqueous tension at 15 degrees Celsius, let that be PMM. So whatever pressure the water vapors they are exerting, let that be PMM. So the pressure of the gas itself is going to be the total pressure minus the pressure exerted by water vapors or minus aqueous tension, and the total pressure is given to us as 750 mm. So 750 mm minus aqueous tension that we have assumed to be Pmm is going to be equal to P1, right? And V1 given to us is that the volume the gas is occupying is 100 ml and the temperature is 15 degrees Celsius. So this is going to be 288 Kelvin. The next part is that we have the gas in the dry state at NTP. So here the pressure therefore is going to be 760 mm and the volume given to us is 92 ml, and the temperature, because this is at normal temperature and pressure, so the temperature is going to be 273 Kelvin. So we put as the ideal gas equation to be P1 V1 over T1 equal to P2 V2 over T2. So putting up the values, what you will be finding out is the value of P, that is the aqueous tension, to be 12.4 mm. So the aqueous tension or the water vapor pressure is going to be 12.4 mm at 15 degrees Celsius. So I hope now you understand how you are going to calculate aqueous tension or how you find out the pressure of a gas in the dry state when the aqueous tension is given to you. So these are the various type of questions which are asked related to the Dalton's law of partial pressure. I hope I have been able to give you a variety of questions that are going to come in the examination, and now you can comfortably try the questions which are given in your books. So that would be all for this lecture, and the next lecture is going to be a really important lecture. Why is it going to be important? Well, because I am going to put to test all your learning that you have done in all the four laws, the ideal gas equation as well as the Dalton's law of partial pressure, into one lecture. And the lecture is going to be on the problems based on containers. What all different type of containers we have, what all is going to be constant in that, what is going to be varying in those containers, is what all is going to be a compilation of all the learning of the previous lectures. So for this very important lecture, if you have not subscribed to the channel till now, please do that and also click on the bell icon. We are trying our level best to give you the best possible education for helping you excel in your examination. All we request you is to please do subscribe to the channel, click on the bell icon for all the information that should come up to you the moment we put up the lectures for you, right? And also, if you like this lecture, please do not leave without clicking on the like link. Thank you and have a nice day. God bless you.